All right, let's talk Trelleborg DrainPacker. If you're here, it's probably because you need the exact pressure specs, right? Well, you've come to the right place. In the next couple of minutes, we're going to pull the precise numbers you need straight from the technical approval doc. No fluff, just the facts to get the job done right. Let's dive in.
Okay, so let's not waste any time. The big question, the one that can make or break a job, is pretty simple. What are the critical pressure specs for a Trelleborg DrainPacker? We're about to give you that specific, actionable data you can take right to the site. Let's get started.
So first things first, the installation phase. This is all about getting that packer inflated just right inside the hose pipe, and you gotta nail this part. Seriously, it's the foundation of the whole repair. If you get this wrong, the entire job could be in trouble right from the get-go.
So what are we even talking about here? An inflatable packer? The easiest way to picture it is like a super tough industrial strength balloon. That's really it. Its whole job is to be a temporary mold, to press that resin-soaked mat firmly and evenly against the inside of the pipe. Sounds simple, right? But man, the precision has to be perfect. And here's the flow of the operation. It's pretty straightforward, really. You get the mat into position, you inflate the packer, and then here's the key. You absolutely have to maintain that exact pressure while the resin cures. You can't let it drop. That constant, unwavering pressure is what gives you that perfect, seamless bond you're looking for.
Okay, so what's the magic number? What pressure are we talking about? Well, the official term in the tech doc is the permissible pressure. And I know what you're thinking. You're probably looking for one single number, right? But it's actually not that simple. See, the right pressure changes based on the pipe's diameter and the specific packer you've got on the truck. And this quote right here, straight from the source, tells you exactly why there isn't just one number for every job. It calls the pressure a key job datum that the lining job manager must arrange to be tested and recorded. Now, listen up, because this is important. This means it's not just some setting on your gauge. No, it's an official piece of data that you have to record for every single project. Your job is to find it, use it, and crucially, document it.
All right, so the liner's in, we can pack up and go home, right? Not so fast. Now we get to the testing phase. This is where you actually prove your work. Prove that the repair is perfectly sealed, totally secure, and ready for years of service. The official approval actually calls for two different tests after you're done. You've got the positive pressure test, which is all about checking the liner's strength. And then there's the tightness test. That one follows the EN 1610 standard, and its whole purpose is to make sure there are absolutely zero leaks. So let's break down the numbers you need for both. Let's start with that positive pressure test. Think of this one as the durability check. We're asking one simple question. Can this new liner handle sustained, real-world pressure without failing? The document gives us a very specific number and time frame to find out. And here it is. The number you need is 0.5 bar. Simple as that. You have to apply water pressure of exactly 0.5 bar and keep it there for a solid 30 minutes. If it holds, you've officially proven the structural integrity of your repair. Job well done. Okay, next up, the tightness test. This is the one that follows the EN 1610 standard. And this test, it's not about raw power. It's about finesse. The goal here is to hunt for even the tiniest leak, to ensure a perfect seal. And to do that, you have to work inside a very specific pressure window. And this lays it out perfectly for you. You're working in a really precise window here. You can't go over a maximum of 50 kilopascals, but at the same time, you have to keep at least 10 kilopascals of pressure. And that's measured at the very top, the crown of the pipe. You got to stay right in that sweet spot. That's how you know for sure you've got a perfect leak-proof seal. Okay, let's recap those testing numbers just to make sure we've got them locked in. Think of this as your quick glance cheat sheet. For the positive pressure test, you're looking at 0.5 bar for 30 minutes. Easy. Then for that EN 1610 tightness test, your zone is between 10 and 50 kPa. Those are your go-to numbers for proving the job was a success. All right, I know we've thrown a few numbers at you pretty fast, so let's just boil it all down. What are the absolute critical numbers you need to walk away with? Let's get to the final takeaway. Here it is, the whole thing in a nutshell. Number 1, for the installation itself, you have to find and, just as importantly, record that job-specific permissible pressure. Number 2, for your positive test, it's 0.5 bar held for 30 minutes. And finally, number 3, for the tightness test, you live in that 10 to 50 kilopascals window. Nail these 3 things and you've done a solid compliant job. Period. And that brings us to one last thought to leave you with. You've got the numbers now, you know the specs, but here's the real question. Is your documentation just as solid as the repair itself? See, knowing this stuff is half the battle, but being able to prove you followed the spec, that's what separates the true professionals from everyone else. Something to think about. Thanks for tuning in.